Hello and welcome to the Jacobi Palletizer tutorial. My name is Swapnil and I'll be walking you through the setup of our Palletizer software. In this video, part 4, we will be exploring how to use our Jacobi Palletizer software to actually configure a setup, plan motions for the boxes to pick up and place boxes as we desire. For this video, it's crucial that you have the Jacobi Palletizer installed, so watch the previous video. You also will need a Jacobi project representing the environment, so watch the video on Studio for that before we get started. We start by checking out our Setup tab. Right now, it's empty, but that's because we haven't planned anything yet. But that's all about to change right now. Let's click here and start making a new setup. First thing we do is in the Project tab, we name our project whatever we'd like. Let's call it Robot Cell Test. And we upload our project. It takes a few moments, but it's done, and we can save and continue. Throughout this process, we will click Save or Save and Continue. This means that the application will remember our progress from when we last clicked Save, if you ever needed to leave in the middle for something. In the next tab, we have our Box tab, where we can define important parameters about the box, its width, length, and height. We can see just how our pick point that we defined in Jacobi Studio comes into play here. That very point serves as a reference, and we can see our box when we change the dimensions and play around with it here, how it gets created. We can even set labels on the box if we want to indicate a sense of directionality. A lot of boxes have labels or directional packaging, which is relevant for palletizing. If you want them to, for example, face outwards on the pallet, we enable this behavior with a simple checkbox. We also allow picking up multiple boxes at once in order to get more efficient palletizing behavior. In that case, we can click this checkbox and the robot will try to pick up 2 boxes, more than one if it can, to make the palletizing go more efficiently. For our tests, let's use this box right here. If we want to give good and accurate measurements, in practice we've observed the best way to give this number is to average out the reading over a couple of boxes. So once we average out the length, width, and height measurements I've just taken here with 3 boxes, we can use a tape measure and division to get us a number that is more reflective of the average box. In practice, boxes warp and bend and come out of production differently, so reflecting this is most effective. Of course, our software doesn't break if a box comes out a little different. We in fact are able to tolerate many different box size variations so long as they're roughly the same as what we specified. But it's good practice to try and minimize the imprecision of measurement this way. Now that our box is specified, we can get to the fun part, making patterns. Within our configurator here, we can add boxes in the scene. In doing so, when we add a box, we can rotate it, drag it around, or delete it entirely. Of course, we're often not content with just one box in the scene, so let's add a grid of boxes. We can do so by using the Add Grid option here, where we can specify the number of rows and columns we want to add in a box. If we want, we can also make a selection of a certain amount of boxes and delete them. We can select another one, Control-C to copy, Control-V to paste. And after this, we can continue to add more layers. Every time we add a new layer, we have the option to either specify a new box pattern for that layer or repeat one from a past layer. Within the options we also have a couple of shortcuts to make your life easier, all shown in this handy tooltip. Once you're happy with a setup and a pattern that you've made, you can save this pattern and you can reuse it in future projects, or load a previously established pattern that you've used in Jacobi Palletizer. After this, we go to the Motion tab, where we can exert some influence over how the motions themselves behave. Do we want to make slight micro adjustments to the pick point? This actually comes up pretty frequently. For example, when we're using a suction gripper with suction cups, we need to add a bit of an extra Z offset because the point where the gripper just touches the box may not give enough of a seal for the suction cups to firmly pick it up. An inch or 2 lower gives it enough to pick up the box. We can even make X and Y adjustments if there were small issues with how the pick point was defined in Studio, and we need to make on-the-fly adjustments. Of course, we recommend making the changes permanently in Studio to reflect the correct state of the world. But similarly, we can influence features like the pick retraction, the place retraction, and the place approach. These are all aspects of the robot's motion that we optimally auto-generate for you, but you can play around with. What if you want the boxes to come in from more of an upwards vertical angle? You can do that. We even have an advanced knob here to let you play around with even more movement features. For example, if you need your robot to run slower when it's holding a box, what if it's holding something valuable or dangerous and you need to ensure more safety? You can do so by playing with the speed. Once you feel comfortable with the parameters you set, let's calculate. Even for a lot of boxes, our motion planner is very fast. And with Jacobi's motion planning, we are able to confirm whether all the motions are possible within a matter of a couple of minutes in the worst case. Once we're done, we can see the motions of the robots themselves in simulation as it places boxes from the conveyor onto each pallet. We can explore the scene and set the speed to watch the whole simulation. We actually even offer details here on box pick rates and performance, so that even in simulation, you have an understanding of the robot's performance before it gets to the real world. Once you feel content with your motions, you can save your setup and activate it. Thanks for watching, and I'll see you in the next video.